Introduction to NSA Mainstreaming Guideline, Session 3. In this section, I'm going to explain about 3 points. First, selection criteria of nutrition-dense food. Second, example of calculation of nutrition value. Third, introduction of NFA tool. How to identify nutrition-dense food. Screening criteria for nutrition-dense food. As we have already discussed, the most important criteria for nutrition-dense food is content of nutrient. It depends on the type of undernutrition we are tackling. So in case of wasting, it is important to look at dietary energy or calorie, and it mainly comes from staples. When we tackle with stunting, protein could be an important nutrition element that is generally included in legume, meat, dairy products, fish products. And when we're looking at anemia, of course, we should look at iron-rich food. So this nutrition content is important, but this is not enough. As you know, crop production is very much dependent on surrounding agricultural condition. So we need to consider a location-specific technical issue. Also, when it comes to diet, it is not universal. I mean, it is not same nationwide. It vary depending on the location, depending on socioeconomic cluster, depending on religion. Yeah, so there could be many socioeconomic factor affecting diet. So social acceptance is also important. And lastly, of course, economic feasibility is important. We cannot get nutritious food if it's too expensive. So those 4 groups are key category. And later on, I will explain how we introduce this screening criteria into smartphone-based application. Okay, next, how to convert total weight into nutrition weight. Please imagine if you have 1 egg, how do you know how much protein you can get from 1 egg? For this purpose, you will use this formula. Total weight multiply nutrient content divided by 100 equal nutrition weight, nutrient weight. So if 1 egg is like 50 gram, then you need to get this nutrition content. Then finally you will get a nutrient weight. Example calculation is in the table below. Let's assume each food item you have 100 gram. And how much protein you can get from each food item. So you can use this nutrition content. From food composition table, you can get this number. So in case of beef, 18.4% is protein. So 100 gram multiply 18.4 divided by 100, you will get a protein weight, 18.4 gram. In case of egg, so if you have 100 gram egg, the protein content is 12.6%. Then you will get 12.6 gram of protein. Now, another application of food composition table. It is common question, how much food item we should prepare for target group, target population. Let's say we are looking for children under 2. Then we can identify a target nutrition, 12 gram protein every day. That is WHO standard. Children under 2 need 12 gram of protein every day. So to satisfy this nutrition target, 12 gram protein every day, how much food item is required? This is a question for this slide. You can apply this formula. So daily food requirement. For example, in case of beef, how much beef is required to satisfy nutrition target or nutrient target, 12 gram of protein? We can use two number, nutrient target, which is currently 12 gram, 12, and nutrient content, that is protein content listed here. So each food item have a different number of nutrient content. Then from these two number, we can derive daily food requirement, which is listed here. So by using two number, nutrition target, 12 gram protein, and nutrient content, percentage for each food item, then we'll get how much these food item we need for children under 2, who are 12 gram protein, who should consume 12 gram of protein every day. By looking at this number, for example, in case of animal meat, it's in between 65 to 70. In case of milk, a little bit big, 353, because majority of milk is just water. So it naturally it is increasing. And 353 gram is roughly, I can say, 2 glasses. So 2 glasses of milk every day can satisfy children's need. And in case of egg, 95 gram, meaning 2 eggs every day. Cowpea, 57 gram, and soybean, 35 gram. So by looking at all the number, probably a realistic approach would be 2 glasses of milk or 1/3 cup of soybean, or combination of these items. Okay. From the previous slide, now we know 35 gram of soybean is required to satisfy nutrition target of children under 2. Next question is how we can get 35 gram of protein every day for their children. We can think of 3 scenarios. Case 1 could be 35 gram of soybean may be acquired through intra-household distribution. The meaning of this is 35 gram of soybean may not be such a big amount, and then it could be just shared from their parents or from their grandparents, small portion from each. Then it will be already 35 gram. So no need to buy or no need to purchase. That is scenario 1. And case 2, probably this some family can purchase this soybean from the market, just buy. We know annual requirement of soybean is 13 kilogram. 35 gram of protein every day, soybean every day is equal to 13 kilogram of soybean annually. Okay, this is just not a big amount, just one medium bag size of soybean. So I think many rural farmer even purchase this. It's not so difficult. Another scenario could be production. Family can produce 35 gram of soybean every day using 0.01 hectare of land, which is 10 meter by 10 meter, assuming that soybean yield is around 1 ton per hectare. So if we understand a concrete number in nutrition requirement, then we can also create realistic or concrete intervention to satisfy the target. So up to here, I hope you have understood what is the nutrient-focused approach, how we can identify nutrition-dense food, and how we can make use of food composition table to calculate required amount of nutrient, protein, vitamin A, or iron, any nutrition. But I also understand this calculation using food composition table is a little complex, and local experts may not familiar with this calculation. So we decided to develop smartphone-based software, so that you don't need to calculate every time. You can just use this application. Next, I'm going to explain what is added value by introducing a nutrient-focused approach. This is one possible application of a nutrient-focused approach into existing nutrition action. In this slide, left side figure shows a very typical case of nutrition action in the community level. Community health worker gathered, go to the local community, gather families who have babies. There, she will explain the importance of nutrition balance and what kind of food item has a good can be a good source of nutrition. And finally, she will demonstrate how to prepare infant meal, complementary feeding. This is extracted from a complementary feeding guideline developed in UNICEF Ethiopia. Yeah, so it says like for the infant meal, the mother should combine 3 portions of cereal plus 1 portion of legume. And if there is available dried meat powder, then she can also add on top of it. So this is a very standard procedure of complementary feeding guidance. One weakness in this established approach is here, identification of the food. In this text, it is explained in general way. 3 portions of cereal, 1 portion of legume. But with the help from agricultural sector, I believe we can improve this part through application of nutrient-focused approach. Agricultural expert can guide together with community health worker what type of food item is available in the local community and what exact amount is required to satisfy the nutrition requirement for the children. That is a possible application of nutrient-focused approach in preparation of complementary feeding. This is another example of how to integrate nutrient-focused approach into existing agricultural program. In many countries, it is very common to develop a crop calendar to support farmers how to optimize workload, productivity, or agricultural income. The idea is probably we can also add another criteria, which is nutrition balance. So if we have a combination of crop in the table, we can also identify how much nutrient can be supplied through specific cropping pattern for each month. So through this process, we can evaluate different type of crop combination from the viewpoint of workload, productivity, economic benefit, and nutrition benefit. That is the idea of a nutrition-sensitive crop calendar. So yeah, this is another proposal of application of nutrient-focused approach. Summary of the session. Nutrition value is always the primary criteria to identify nutrition-dense food. But we also need to consider other factors such as socio-economic acceptability, technical feasibility, and economic feasibility to introduce some commodity as nutrition-dense food. Second, by calculating nutrition value using food composition table, we can design nutrition action more concretely and practically. Third, NFA2 is an application to support identification of nutrition gap and locally suitable commodity to fill identified nutrition gap. Thank you.